welcome back. We're looking at arc measures, and this is slightly different from arc length. And I'm going to take a moment to kind of go over that really quick. Talking about arc. Look back at our definition of arc length. Arc length is this fractional distance of the circumference of a circle that's defined by an arc. So with arc length, it's a piece of circumference, part of the diameter all the way around. And yes, an arc is the same thing, but we need to talk about how we can calculate the measures of these and not the length of how much a string or fence or ribbon or something that we physically need. So the length of that arc, just how far we have to sweep around the circle in order to trace out, show how much of the circle. It's going to be a very something kind of important to think about when we're the next item, arc length. Right, so what I want to say first is that arcs can be measured in degrees. Actually, the measures of arcs, their length, but the measure of arcs is given in degrees, just like angles. So let's do real quick. I'm going to freehand a circle here. I'm going to have its center at, and it's going to have some sort of central angle coming out this. The measure of this central angle is going to be 30 degrees. And where that central angle crosses the circle itself, go ahead and name. That way we can talk about this arc right in. So we can say that this central angle here, S, measures 30 degrees. So in of central angle S, 30 degrees. When an arc is created by a central angle, it is going to have the same measure as the central angle that created it. Arc S also be 30 degrees because arc S has been created by this central angle. And the measure of the central angle QPS is 30 degrees. Just realizing now that my voice is cutting in and out a little bit, so I'm going to go ahead and lower the threshold just a little bit. There we go. All right, that should be a little bit better in terms of the voice not cutting in and out. So because the measure of the central angle QPS is 30 degrees, the arc that it creates along the outside edge of the circle is also going to be 30. Coming up next, we're going to talk about the measure of the minor arc. So let's review really quickly what the minor arc is. So here is the vocabulary word for the minor arc. Minor arc is the arc of a circle whose length is going to be less than the length of the semicircle. In terms of the measure of an arc, where we're talking about the degrees, the measure of a minor arc, and let me go ahead and label here off to the right. So this was talking about, here we're going to talk about the minor arc. Let's sketch ourselves really quickly a circle. Label its center as S, and then it has some arc Q and N. The minor arc would be this one right here. Notice how its distance is going to be less than if we'd created this semicircle over this way. I'm going to write the name of this other point out here that's creating this diameter. Remember that a semicircle is arc that goes from end point of diameter to end point of diameter, and the minor arc is whatever arc that's smaller than that. Which means that since the measure of the central angle, if we think of the radius as creating this angle right in here, that angle theta, so the measure of this angle SN is creating this minor arc UN. Those measures are equal as per the arc measure that we went over right above us. But notice how this is going to be less than 180 degrees, less than a 1 semicircle. So it needs to be less than a semicircle. And so we're going to think of this as just. Now I said it needs to be less than a semicircle, and I had mentioned that it needs to be less than 180 degrees, and here's the reason. Because if we look at the measure of a semicircle, we will notice that a semicircle is created by a diameter. So if we have the exact same setup, here it is. We have the exact same setup, some circle, and I've traced out a diameter this time. Notice the kind of line that is being created right here between the endpoints of the diameter L and N. This is just some sort of straight line. But arcs aren't measured off of lines, they're measured off of central angles. So what is the angle that is creating this diameter? This is angle L, vertex U, other end N. This angle is a straight line, a straight angle. So angle LUN is a straight angle. And recall from the beginning of the year when we were classifying angles that a straight angle had a measure of 180 degrees. Which means that this semicircle arc right here that goes from the endpoint L, traces up through this A that's sitting on the circle, down to the other endpoint of my diameter N, the measure of that arc, LAN, is also going to be 180 degrees. There's one more type of arc that I want to get into, and that is our major arc. Recall from our definition that a major arc is an arc whose length is going to be bigger than the length of the semicircle, which means its measure, its degree measure, is also going to be greater than that of a semicircle. Which means if I had, whoops, that's not a very straight diameter, is it? Sorry, let me bust out my straight edge here. That's the diameter I was thinking about, that one right there. So if I had this circle with some sort of diameter, and I put in some letters here, this major arc that goes from B, faces all the way around past T and then back up to A. Notice how this arc right here definitely way bigger than a semicircle. That measure of that angle going to vertex X, coming out to vertex A, is that odd angle. That angle is greater than 180 degrees. That was that reflex angle that we talked about way at the beginning of the year. They're coming back now at this angle right here. But we're also looking at this arc measure, and so the measure of the arc B tracing around through point T all the way up to its other end point A, also going to be greater than 180. This is because it is going to be more than our semicircle. Okay, there will be some items like this on our walkthrough, so be watchful for that and keep these definitions in mind. Thanks, we'll see you on the next video and in class.